welcome back to another video. Today's first question is, the product of the 3-digit number ABC and the single-digit number D is 1,673. If ABC and D represent different digits, then what 3-digit number does ABC represent? So first of all, there is a very simple way to do this, and that is first finding what single digit 1,673 is divisible by. So immediately you can cross out all the even numbers because it obviously does not end in an even number. You can cross out 3 and 9 because that's not divisible either, because added together it's 17. So we can try 7. If we divide 1673 by 7, pull up a 2, you get 14. Go to 7, you would have to go up a 3, get 21, you get 6, move down the 3, 63, so that's a 9. So 239. So the 3-digit number is 239 because, as you can see, if D is 7 in this situation, and all the digits are different, so D is 7, then ABC would be 239 because 239 times 7 is 1,673. So equals 239. I'm just box that in. Moving on to problem number 2, a lucky year is one in which at least one date when written in the form month-day year has the following property. The product of the month times today equals the last 2 digits of the year. For example, 1956 is a lucky year because it has the date 7/8/56 and 7 times 8 equals 56. Which of the following is not a lucky year? 1990, 1991, 1992, 1993, or 1994? So this problem is a little bit trickier than the one above because it kind of throws you a loophole at the very, very end, because one number that you think is obviously crossed out isn't actually crossed out. And I'll explain that later. You know that 1990 is definitely out because 9 times 10 is already 1990. 1991, if you go 91 divided by 7, pull up a 1, then you would get 7, 2, 1, 3. This is 13. So let me just shrink this real quick and move into the corner so you can see my calculations later. And here we go. Okay. So this would be 7 times 13. That is an eligible part of the year, so we can cross that out. And keep what I just said about the eligible part of the year in mind, because if the other number exceeds either 12 or it exceeds 31, then that year is not possible because there is no date of day after 31 and there is no month after 12. So 1992, you cannot divide this by 2 in this case because 92 is way too large, but you can divide it by 4 because if you divide by 4, 25 fours is 100. So you minus 2 fours, 23 fours, and 23 is a working number. 1993, you can divide this by 3. If you divide 93 by 3, you would get 31. So since March is one of those large years, count on your knuckles. This works as well. 1994 is the last one left, so you might think, oh my gosh, you've made a mistake here. Why is 1994 here? It's kind of the same reason why I also crossed out 1992 for 2. Because the only number that you can divide by in this case that is less than 12 is 2. But if you divide it by 2, then you would get, if you divide 94 by 2, if you go up a 4, you get 8, you go 1, 14. There is no day 47 in any month. So that is why 1994 is the answer. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I'll see you guys on the next one. Bye!